Hi, good morning. It's Jim from the maverickstar Observatory. Before we begin, apologies for the sound quality in yesterday's video. It's really frustrating when you spend, an hour or so, or probably a little bit more, putting the video together, and then to discover once you've uploaded it onto YouTube that the audio quality is absolutely diabolical. So hopefully in today's video we won't have that problem. We want to talk about a little bit more in detail with regards to the seasons that we experience and what's going on with our magnetosphere, and that's why we've got 4 stills of 2019 during the 4 main seasons. We'll talk about that in just a short while, but I just want to say a huge thank you to those people that have supported us yesterday, even despite the audio quality. I can't thank you enough, and I'm pretty sure that a lot of the subscribers can't thank you enough as well. We are in a bit of a dilemma here. We're struggling to raise funds, not just for the equipment that we're trying to get out, but also improve the content of the videos that we do on YouTube. And the only way we can do that is by, investing more into, a new computer, perhaps a green screen, some more cameras, and we could be looking at these images whilst I'm talking at the same time, as well as other things. It just improves the content, but the only way we can do that is by making an investment. And I've been looking at a new computer, and to do what we want here, and obviously it's not just got to provide better visual content for you, but it's also got to be able to do all the number crunching with the data that we get. Just to give you an idea, some of the TriMag data that we process once a month on the 17th has something like 300,000 entry points. So 300,000 separate pieces of information that has to be rendered. This computer takes ages to do that. And then, when you're trying to upload things and download things and, and add more to the screen and just improve the content, it's just very difficult. So, until we get more money in, things have just got to remain limping along like they are. And, I can only apologise for, when we have days like yesterday and the sound quality is just absolutely ridiculous. I'll do my best at the end of the day, and like I say, it is generally just me here at the observatory, and I have to do the electronics, the programming. We brought about a month and a half ago, 2 months ago, a 3D printer. I'm having problems with that even now. The only thing I can describe it being like is trying to set up a MIG welder and get that welding sweet every time you use it. And if you've ever used a welder, you'll know that they never do. Anyhow, moving on, guys, with this. So just a big thank you to those guys, anyhow, and our patrons. What I've done is I've took a section of video from Batsarus modelling of the magnetosphere, so that we can see a little bit more clearly what's happening throughout the season. So on the first top left hand screen, you've got one close to winter. It's from the 1st of January, and then the next one down is on the 1st of July in summer. Remember, I was telling you that the plasmasphere, which is what we're interested in the plasmasphere and the cusp. The plasmasphere in the one in January is angled towards the top right hand corner of the screen, and that's in the winter time. And then the one beneath that on the 1st of July is angled slightly down. Now when I run the video, you'll see that it will angle a little bit more down, and the reason for that is, the reason why I've stopped it at these particular points is so that we can see where the magnetosheath is failing to that cusp closest to the sun, and you can see the magnetosheath disappearing into the plasmasphere there, and allowing radiation into the Van Allen belt, because the plasmasphere is where the Van Allen belt is, that area where it traps all that energy into the sun. That's where the bow shock fails to block out the radiation from the sun and allows it to creep through. This is what I was telling you about. First of all, we're now in the understanding that the magnetosphere is seasonal, and you can see on the 2 right hand side screens, they're pretty much the same. The magnetosphere is at a horizontal position, and it's interesting, isn't it? because at that time, if you look at the dates that I've selected, I think it's March and October, this is spring and autumn, and we're neither in winter or summer at that point. And isn't it interesting that that is the case, and the magnetosphere is at a horizontal position, pretty much doing nothing. If you look at the two on the left again, you'll see the one in the winter and the one in the summer. The angles that are closest to the sun with regards to the cusp, it allows just a creepage of energy to go into that plasmasphere or the Van Allen belt, and when it does, that obviously has an effect on whether it's winter over the northern hemisphere or winter over the southern hemisphere, and likewise summer over the northern hemisphere and summer over the southern hemisphere. So I don't think many of these organisations have come out and told people about this. They must be fully aware of it. I checked back a good 6 years to make sure the point that I'm bringing up about the angles are accurate. The only thing that changes the angles is when you get high pressure density of radiation off the sun hitting the bow shock and going into the magnetosheath, and then in turn going into the cusp, and it can also change the angle. And I guess the reason for that is because it's the position of the coronal mass ejection that's coming off the sun at that time. Because if we've got coronal holes that are erupting, and the sun is an immense size compared to the Earth, we could have over the northern hemisphere of the sun a CME erupt, and that could affect the position then of the angle at which it hits our magnetosphere, and then in turn creeps into the magnetosheath, and then into the cusp, and then into the plasmasphere. So there's a lot of mechanics with our magnetosphere, and it's all generated from the magneto within the Earth. And this is another point I want to make. If the poles have been in migration from the 1900s to the present date, and the dipoles have been moving, like the magnetic North Pole has been migrating, a good couple of thousand miles now, then the angle of rotation on the magnetosphere, I would have, logically thought, would have shifted also. And if that is the case, then, as this magnetic pole goes through its reversal, it could, and I've done some drawings to test this theory, it looks very plausible, it could put our magnetosphere into a position where we have an autumn and a spring horizontal line during the summer months and the winter months in the future. If that is the case, I'm convinced it is going to affect our weather even more so, not just for the fact that we're getting more cosmic rays come through as a result of a weakened magnetosphere, but as a result of the position of the magnetosphere or the plasmasphere in general. And that could then bring the temperatures down, I would expect, on the planet. Another thing I want to do is just go back to the map that we was looking at. I'm just going to run these videos so you get an idea of what I'm talking about, when we start getting pressure hit the magnetosphere at different points of the year, how it can change the position of the photosphere temporarily. But in general, like I say, I went back a good few years checking the seasons, and what I'm saying is correct, given the fact we don't have pressure coming off the sun through a CME, because that changes the picture altogether. But in general, you can see the angles during the winter, the summer, the spring and the autumn are at different positions, and that's because we're at different angles as we go around the orbit of the sun. And what I want to make clear is that the tilt of the Earth doesn't change. It's just the fact that in summer over the northern hemisphere, the tilt could be in favour of being closer to the sun, but if we go 6 months later, we've gone round the sun halfway, and that tilt of the Earth is further away, putting the places like in the northern hemisphere here in the UK in that winter. So, but in general, it is true, the magnetosphere is seasonal, and I do believe for that fact that it has an effect on our weather. So I'll just let it run just a little bit longer so that you can see what happens. I mean, I think I'm at the maximum I'm allowed to show given a time period slot, and that's 200 frames at around 3 frames per second, so gives you an idea. I think it's a good idea if I just show you a quick diagram, because I've mentioned the magnetosheath, the cusp, the plasmasphere, the bow shock. So if I just show you a quick diagram before we end looking at these, and then move on to the map, I just want to talk about what could be a possibility for Russia, that district in Russia, as the pole migrates towards it. So as you can see, we're looking at the diagram of the magnetosphere. You can see the bow shock, the plasmasphere, the plasma sheet, the neutral point, and the magnetail, and also the magnetosheath. Then you've got the magnetopores, and then you've got the cusp. What we're interested in is the position of the plasmasphere, which is the Valanian belt, and the cusp, which is that vulnerable area where a lot of the energy seems to creep in to the plasmasphere. And you know, it is the plasmasphere and not so much the magnetosphere sheath, the magnetosheath, that is the bit that's moving during the seasons. The magnetosheath is relatively kept in the same position, but it is the magnetosphere that seems to be adjusting with the position at different times of the year, and therefore, you know, falling in line with specific seasons. And I believe that this is another key contributor to global climate. You know, perhaps with more study on this, we'll find out a little bit more whether that is the case. And you know, maybe if we do a little bit more research, there might be some astrophysicists that have actually published work on this themselves. So yesterday I was talking about where the magnetic North Pole is going to end up at some point in the future. Now, at its current speed, we know it migrates around 4 miles per month. The Krasniki region, that little white dot on the Earth here, is where the epicenter is on the map of the highest intensity, and we know that's where the magnetic North Pole is absolutely 100% heading towards. And at its current speed, yeah, you might have already done the math, 1,400 miles over, you know, moving at 4 miles a year is around about moving at 4 miles a month is around about 29.1 miles. 29.1 years at its current speed, but we know it's moving very fast towards you know, that 40-degree mark, and it is through the experiments that we've conducted here at the observatory, and reasonably using just logic sense, predict that at that point it will have moved 40 degrees, and it will be leaving the strong field lines which hold it in its position longer. And once it does that, it moves into the weak field lines, and that's when poles move very quickly. So although at its current speed it could be 29.1 years away, it's not going to do that. And we've seen from the nature already that recently, over the last 30 years, the pole has started to go up a gear, move a lot faster, covering more distance over short spaces of time. So, you know, we are accurately predicting the trajectory now. If you look at the corridor of where the pole and the pins are previously there at the top of the screen, you'll see that it is in line for the Krasniki region, and you know, it will be there, I believe, within the next, say, 3 to 7 years, especially when we get past that 40-degree mark, you know, and enter the weak field lines. We know that once it gets to the Krasniki region in Russia, it's not going to hold up there either, because at that point, I believe that as we are getting closer with the dipole, or the magnetic North Pole, as it gets closer to the Krasniki region, the intensity over the Krasniki region there now is going to continue moving south towards the equator, and the high intensity region, and where we've got the South Pole in the centre, is going to continue moving up towards the equator. And we know that the opposites attract each other with regards to magnetic poles and for that reason we're going to see the reversal take place. But before that happens, something else is going to take place on this Earth. One, we're going to have a weakened magnetosphere, which is going to allow a lot more cosmic radiation in. Two, we're going to have a shift in Arctic region. Now the region that we're talking about, I keep getting it wrong, the Krasnaya region in Russia is just outside the Arctic Circle, and if that becomes the new epicenter for the Arctic Circle, then the Arctic circles on our planet are going to look a lot different, and it's going to put a lot of sub-zero temperatures on one side of the Earth, because we've got almost these two poles now coming towards each other on one specific location of our planet. And if that is the case, and it does carry the Arctic climates with it, the majority of the land above water on our planet is going to look a lot colder. This could be what puts planets into ice ages. We really don't know. We can follow the evidence to support that, and at some point I suppose all the bits do fall into place, like they are almost certainly doing right now with the study now of the magnetosphere and the high intensity regions. And that's why we've been putting our magnetometers in the locations where we have. My wife, as you know, is from Lithuania. She speaks very good Russian, and we are going to do a video where she just converts English into Russian for me, and that is to get some now subscribers from Russia, and hopefully so we can get one of our magnetometers and muon detectors into Russia, because we've struggled to do that. So hopefully with her interpretation we can get a bit of more encouragement over that region and get these magnetometers and muon detectors out into that particular spot on the Earth. So setting the pole shift and the weakening magnetosphere just aside for a little while and concentrating on what we talk about, the heliosphere, this model from the Computer Community Modelling Centre gives us a good outlook of what's happening to the Sun's heliosphere. Now I've selected for the purpose of just demonstrating the time that we're in right now compared to the last solar maximum. So I've gone back to almost the time where we was at solar maximum 2015, and obviously we're looking at the present time, and you can see that during solar maximum, even though it was a real weak solar maximum, there was still more density and pressure of solar activity compared to today. The other good thing about this is we get to see the other planets within our solar system, and it focuses also on the centre and right panel of each box, what's happening and what's coming with regards to solar pressure and density towards Earth. So the yellow dot in both these captions are the Earth in those two boxes, and then on the left hand side we've got the rest of the planets. But you can see the density and pressure is a lot higher in 2015 compared to now, and that is because we're in a grand solar minimum, and this also means we're getting more cosmic rays as a result. I mean, I could prove it just by showing you the space environment overview of 2015, as I've done many times. I think it's a good idea just to get a recap on that. But as you can see, there's a lot more solar pressure and density during 2015. We was in a very weak solar maximum at that point, and we're in solar minimum right now, and there's the disclaimer. So I am showing you what happens at two different intervals, but you've got to bear this in mind. Solar cycle 24 around 2015 was at its maximum, and it was a very weak solar cycle. So even though we are seeing just moderately slightly higher dynamic pressure to what we are today, it is still not enough, even in 2015, to block out at the point of solar maximum the majority of the cosmic rays that we're having inbound now. So we have got a compiling problem right now at this time. And I know the bacon and eggs that we have for breakfast in the morning distracts us from all these things that are taking place, but they are taking place very slowly. We're very slowly noticing the weather changes. Some of us, if we compared the weather changes to when we were children, 20 years ago, 30 years ago, we would know that the summers aren't just quite what they was back then. And we remember these things, but when we're being slow boiled with these gradual changes, it's hard to notice the difference. And that's why we go about our business as though nothing's happening. But what's on the big scale of things, even though things are happening slowly, the agricultural land around our world is being affected. The food production that we have right now is being affected, and I find that really shocking, because we've never had so many people on this planet that need those things. And now we're starting to see arable, good agricultural land go offline through the changing of seasons as a result of this, what we're looking at right now. A weakened heliosphere, a weakened magnetosphere, a planet with its major mechanics shifting, like the poles, the magnetosphere, and as a result, we don't see the danger clearly through all these changes, but they are slowly creeping up and catching up with us. And even today, I believe we're starting to feel the effects of them. So, like I've pointed out before, the red horizontal lines are the points that I want to draw your attention to, because the vertical line falls slap bang at the solar maximum of 22 cycle, 23 cycle and 24 cycle, the current one that we're at the end at now. And you can see where the horizontal lines that I've marked on there are times during 22 and 23 where solar maximum was strong enough to push out the cosmic rays, if you look at the third chart down. But compare that to solar cycle 24, you'll see that even at the maximum of the cycle, it still allowed cosmic radiation inbound. And we are looking at something that is dropping off. If I just get something up to show you a little bit more visually, you'll see that pattern for yourself. Solar cycle 22 was stronger than 23, 23 was stronger than 24, and there is an exponential decline in sunspot cycles, the activity within the cycle. So we haven't reached equilibrium yet with grand solar minimum. The other important point I want to make out here, guys, is that when people talk about, on other channels, they talk about solar cycles, and they talk about the one during the Maunder minimum, and they get confused. They say that the lack of sunspot activity put the Earth in an ice age, and it's incorrect. The ice age began 50 years before the Maunder minimum, where we experienced low sunspot numbers. So it wasn't the fact that we had decaying sunspots that drove the temperature down, because the temperature was already down 50 years before that. I just want to make that clear, because people still today refer to the Maunder minimum as a time where we was at low solar activity, and they conclude that it was the low solar activity that drove the temperatures down. But if you look at the chart, you'll see the ice age, the little ice age, began 50 years before the Maunder minimum. So 50 years before the sunspots dropped off. Just proves that it wasn't the sunspots dropping off that allowed more cooler temperatures to occur. There's a lot we've got to learn, and a lot we've got to piece together. And the only way we can do that is by continue investigating all these things. I do believe now, looking at the modelling systems that we've been looking at over the last few days, in particular with the plasmasphere changing according to the seasons, I do believe that it is a contributor to driving climate. I don't find it coincidence that during the spring and the autumn it's vertical, and that during the winter and the summer it's pointing up and pointing down at other times. There's more to it. And that's why I think we need to now start incorporating more of these images that we've got coming through from the computer community modelling centre, such as ISWA and the Batarus magnetosphere modelling. Guys, I'm going to leave it here. I hope I'm clearing up things. Gradually I'm trying to incorporate a little bit more charts and modeling systems into these videos that we're uploading now, as well as continuing to put out equipment at different locations and always improve what we're doing now. It is an awkward time for us. The COVID-19 has changed the dynamics of the way we make revenue for what we do here at the observatory. So a big thanks for those of you that are sticking in with us. Big thank you to all those that have supported us over the last week. And if I could encourage more people to just continue supporting this observatory, we'll keep bringing you up to date with all the changes, and also hopefully educating you on these topics and anomalies that we talk about here, so that you get a better understanding of what it is that is changing in your world. Okay, I'll say there's a link down there if you want to support us, and also you can support us on Patreon. And with that, guys, I'll bid you a very good day, and I'll catch up with you perhaps at some other point in the week. As always, bye for now.